Yeah, welcome back to the second lesson of the definition and calculations of pOH. We're going to be looking at the pOH calculations. What is pOH? pOH is a measure of the concentration of hydroxyl ion in a solution. That is, the measure of the alkalinity of a solution. Now, from this definition and the definition given in pH, we can also derive that pOH of a solution will be equal to minus log to base 10 of hydroxyl ion concentration. Now, for any dilute solution, our pH plus pOH will be equal to 14 for any dilute solution. So from here, we can have our pH to be equal to 14, and this moves here, minus pOH. Also, we can have pOH to be equal to 14, then this pH moves here, minus pH. So that is for any dilute solution. Now, for a solution that is neutral, when we say a neutral solution, it is a solution that has a pH equal to 7, meaning your pH also equals to your pOH. So, for a neutral solution, our pH equals to pOH and has a value of 7, which means each of them has a value of 7. So, which means the concentration of hydrogen ion multiplied by the concentration of hydroxyl ion will equals to 1.00 multiplied by 10 raised power minus 14. That is for a neutral solution in which the pH equals to pOH. Now, from these equations, the major equation here are, this is the first equation, this is the second equation. From the second equation, we can derive these two equations. And this is the third equation. So we are going to be making use of these three equations in our calculations. Example 1, question A. What is the hydroxyl ion concentration in a solution of pOH of 5.55? B. What is the hydrozonium ion concentration in the same solution? To solve this, in the question A, we want to calculate the hydroxyl ion concentration if given a pOH of 5.55. And we know that pOH of a solution equals to minus log to base 10 of hydroxyl ion concentration. Now let's input our values here. We have 5.5 here, 5.55 equals to minus log of hydrogen ion concentration to base 10. Now multiply both sides by this negative, by minus. We are going to have minus 5.55 equals to log to base 10 of hydroxyl ion concentration. Let's take the unknown to the left hand side. So we have log of hydroxyl ion concentration to base 10 equals to minus 5.55. Now, our concentration of hydroxyl ion, as we did under pH, will be equals to antilogarithm of minus 5.55. Let's take our calculator as well to press second function or shift and press minus 5.55. We're going to be given our value to be 2.82 multiplied by 10 raised to the power minus 6. This is concentration. It means the unit is mole per dm cube. So that is the concentration of hydroxyl ion. For question B, if you could recall, we got our concentration of hydroxyl ion to be equal to 2.82 times 10 raised to the power minus 6 mole per dm cube, and we want to find the concentration of hydroxonium ion. And don't forget, either hydroxonium ion or hydrogen ion, we are good to go. They are the same. So if you recall, one of the formulas that says concentration of hydroxyl ion multiplied by concentration of the hydroxonium ion equals to 10 raised to the power minus 14. Don't forget, either it is hydrogen ion or it is hydroxonium ion, is the same. So here we have the value 2.82 times 10 raised to the power minus 6 multiplied by hydroxonium ion equals to 10 raised to the power minus 14. So since what is joining them is multiplication, we divide both sides by this value. So we have concentration of hydroxonium ion will equals to 10 raised to the power minus 14 divided by 2.82 times 10 raised to the power minus 6, meaning we have 1 divided by 2.82 multiplied by pick one of these 10 raised to the power minus 14. This division in logarithm changes to minus, as well in indices changes to minus. Then we have minus 6. So from here, when you divide 1 divided by 2.82, we have 3.55. So our concentration of the hydroxonium ion will equals to 3.55 multiplied by 10 raised to the power minus 14. Minus times minus, we have plus 6. So which have 3.55 multiplied by 10 raised to the power. So minus 14 plus 6 gives minus 9. So mole per dm cube. So this is the value of hydroxonium ion. Example 2. A glass cup of orange juice is found to have a pOH of 11.40. Calculate the concentration of the hydrogen ions in the juice. This is one of the exam in Nigeria, NECO, called NECO. Now, when we look at this question, look at these parameters that we have here. We have a glass cup of orange juice is found to have a pOH of 11.4. Let's write that down. pOH equals to 11.40. Then calculate the concentration of the hydrogen ions in the juice. Concentration of hydrogen ion is given thus, unknown. Now, let us now look for, since we are given pOH, we start from known to unknown. So, a formula that contains pOH, from the three formulas we wrote. From the three formulae we wrote. So, we have pOH plus pH is equals to 14. So, from here, we can get the value of pH. Then, our pOH here is 11.40 plus pH is equal to 14. Then, collect like term. This moves here. So, this positive sign will change to negative. pH will equal to 14 minus 11.40. So, our pH equals to, so when you subtract this, we are going to have 2.6. 2.6. So that is the pH of this question. But the question says we should calculate the concentration of hydrogen ion. So from this pH, we are good to go. We can now say that pH of a solution equals to minus log to base 10 of hydrogen ion concentration. So we input our value here. Our pH here is 2.6. So we have 2.6 is equal to minus log to base 10 of hydrogen ion concentration. Multiply both sides by negative sign. We have minus 2.6 equals to log to base 10 of hydrogen ion concentration. So from here, we can now calculate the concentration of the hydrogen ion to be equals to antilogarithm of minus 2.6. So when you now take your calculator and press our antilogarithm, it gives 2.51 times 10 raised to the power minus 3. Since its concentration is going to be in mole per dm cube. So that is the concentration of hydrogen ion in this solution. Now, example 2. The question reads thus: a glass cup of orange juice is found to have a pOH of 11.40. Calculate the concentration of the hydrogen ions in the juice. And this is the NECO question, one of the exam in Nigeria. Now, if you could recall, in our previous formula, we have that pH plus pOH is equals to 14. And from this question, we are given the pOH to be equal to 11.4. Now, when we substitute, here we have pH plus 11.40 is equals to 14. So, my pH, when you collect like 10, 11.40 moves to the other side, and this sign changes to minus. So, we have 14 minus 11.40. So, my pH then will equals to, my pH will equals to 2.60. Since my pH equals to 2.60, and we are asked to calculate the concentration of the hydrogen ions in the juice. Now, by using the formula for pH, pH is equals to minus log to base 10 of hydrogen ion concentration. So let's substitute. 2.6 is equals to minus log to base 10 of hydrogen ion concentration. From here, let's multiply both sides by this minus 1, that's negative 1. So here we have minus 2.6 is equals to log to base 10, condition of H plus. Now let's take the unknown to the left hand side and the known to the right hand side. So this comes here. We have log to base 10 of hydrogen ion concentration to now be equals to minus 2.6. So to calculate the concentration of hydrogen ion is going to be equals to the antilogarithm, the antilog of minus 2.6. So from here, the concentration of hydrogen ion. So when you press our calculating machine, the concentration of the hydrogen ion, when you press to get your antilogarithm, you are going to press shift or second function, then press your logarithm. It gives you antilogarithm. Press minus 2.6, and we have the value of 2.51 times 10 raised to the power minus 3. 2.51 times 10 raised to the power minus 3 mole per dm. So that is the condition of the hydrogen ion in this question. This is an assignment for you in order to test our knowledge on the understanding of this topic. Question 1 reads thus: calculate the, question A, concentration of hydroxonium ion in 0.025 mole per dm cube in aqueous solution of HCl. Question B, calculate the pH and pOH of the solution in A above. This is a wide question. Question 2, a sample of fruit juice has a pH of 4.2. What is the concentration in mole per dm cube of hydroxide ion in the juice? So, don't forget to subscribe by hitting the subscribe button, and as well, click the notification bell for my subsequent contents. You can also help your other learners by sharing, like, and comment on this video. I see you in my next video. Thank you.